Hello everyone. As in the last question we have seen that if on the left hand side the denominator of the two fractions are already conjugate to each other, then it is possible to take the LCM of these numbers. Now if this is equals to p plus q under root 5, first of all we have to rationalize the denominator. For that we have taken 3 plus under root 5 multiplied by 3 minus under root 5 as the LCM of these two. Now the first will be 7 plus 3 root 5 has to be multiplied by 3 minus root 5 minus. I already told you that it is always better to take two terms into the bracket so that we will be able to correct the sign in between the two terms. 7 minus 3 root 5 multiplied by 3 plus under root 5. Now, if in case they are not the conjugate, then we have to solve both individually. But if in case they are the conjugate to themselves, we can directly take the LCM and solve it. Now, when we multiply, then 7 3 are 21 minus 7 under root 5 plus 9 under root 5 minus 3 into 5, that is 15. This term multiplied by 3 minus root 5. Then it is minus 7 multiplied by 3 is 21. Then 7 multiplied by root 5 is plus 7 root 5. 3 root 5 minus multiplied by 3 is minus 9 root 5. And minus 3 root 5 multiplied by root 5 is minus 15. So this is the numerator upon. Again, as I already told that how we solve the two terms in the denominator and how to rationalize them. So we have to multiply both in the format of x plus y multiplied by x minus y, which is x square minus y square. So 3 into 3 is 9 minus 5, which is equals to p plus q under root of 5. Now when we solve this bracket, all the terms, all the signs will be changed. So this will be negative, then this will also be negative, this will become positive, and this will become positive, and the bracket can be evaded. 21 can be cancelled out by 21, then 15 can be cancelled by 15. So the remaining term is 18 root 5 minus 14 root 5, that is 4 under root 5 upon p minus q is 4, which is equals to p plus q under root of 5. Now these two can also be cancelled out. Now as we have cancelled out these numbers, now it is very clear, very evident that what should be the values, because the rational term has to be equated with the rational term, which is 0, and the irrational term has to be equated with irrational. So the value of p becomes 0 and the value of q under root 5 is equals to under root of 5. And through which we cancel it out, the value of q becomes 1. So the value of p and the value of q are rational number. P is having a value 0 and q is having a value 1. Here we have to keep one thing in mind, that 0 is a rational number. Because the definition of rational number is which can be put in the form of p upon q, and where q should not be equal to 0. It is possible that the numerator is 0 but the denominator should not be equal to 0. So 0 can be written as 0 upon 1 or 0 upon 2 or any other rational figure. So this way we can solve the question of the question number 5, where we have to find the value of p upon q. In the next class we will talk about question number 6 onwards. If you have any problem, you can contact us or email us. Thank you.